Sure, we'll start. So I think we have seen in last lecture Fourier Sine transform. Now we'll go with the next topic, that is Fourier Cosine transform. Give the heading Fourier Cosine transform. So what do you think? What can be the definition?
F of s is equal to under root 2 upon pi integration 0 to infinity f of x cos x dx.
Okay, instead f of s, as it is cosine, we have used FSS for Fourier sine. So for cosine, you will use FCS. F of s, but cosine. So Fourier cosine transform, yes, it is root 2 by pi integration from 0 to infinity f of x into what?
Cos x dx.
Cos sx dx. This is the Fourier cosine transform, and yes, it is obviously defined on the interval 0 to infinity. Function must be over this interval 0 to infinity. Right, so we can see the question. Find the Fourier cosine transform of f of x is equal to 1 in 0 to 1 and 0 when x is greater than 1. Okay, this is your first question. Function is given and it is asked the Fourier cosine transform. Means FCS. Write the definition first. Integration 0 to infinity f of x cos sx dx. But what is function f of x? Is
1.
1. And what is the interval?
0 to 1.
Right. So 0 to 1, 1 into cos sx dx. So you have to here integrate cos. What is the integration of cos?
Sin.
Sine. Sx upon what?
S.
S. As it is with respect to x. S is constant. It is from 0 to 1. Means you are writing for upper limit 1 instead x. As it is with respect to x, x you are writing first as 1. So it is sine s upon s minus lower limit you are writing 0. So sine 0 is
0.
So you get your answer as root 2 by pi into sine s upon s as Fourier cosine transform. Such questions can be asked. Is there? Just a little difference from sine to cosine is this. There is cos. Any doubt in this?
No.
Right. Write the next question. Try to solve. Second, find the Fourier cosine again of f of x is cos kx in 0 to 0 is less than x is less than a and 0 when x is greater than a. Find its Fourier cosine transform. So first you should write the definition FCS root 2 by pi 0 to infinity f of x into cos sx dx. So try to solve this. Here it is 0. Limits of the integration are from 0 to a, right? And the function is
Cos kx.
cos kx into cos sx dx. We cannot separate, but we have a formula. Which formula?
Cos equals to.
Right. So you should write 2 by 2. So that 2 will come out into root 2 by pi. Integration 0 to a 2 cos a cos b. What is 2 cc?
cos A plus B plus cos A minus B.
plus
Right.
cos A minus B.
Right. So it is cos A plus B. K plus Sx. K plus Sx. Plus cos A minus B. So K minus Sx dx. Now integration gets separate, and this 2 is nothing but root 2 into root 2. There 1 root 2 will get cancelled. Right? So it is 1 upon root 2 into root pi, that is root 2 into pi. What is integration of cos?
Sine.
Sine. Sine k plus s x upon what?
K plus S.
Right, k plus s. Plus same again, integration of cos sine k minus sx upon k minus s from 0 to a. Now put the upper lower limits. For x, upper limit is a, so it is sine k plus s a upon k plus s plus sine k minus s a upon k minus s minus lower limit you are writing x is 0.
0.
Sine 0, right? It is 0. And same here, sine 0. This is also 0. So only this part will be in the answer finally. So you can ignore this 0, 0 part as the value is 0. So yes, this is your answer. I think you got now. It is exactly similar as sine
Sine.
transform. Just you have to change only that sine by cos. So we now can see inverse Fourier cosine transform. Give the heading inverse Fourier cosine transform. It can be IFCT, and the last one can be Fourier cosine transform. It is FCT. Short forms. Okay, so can you tell me the definition?
Yes.
Chalo, come on.
F of x is equal to under root
F
2
of
upon pi.
x is right under root 2 by pi.
0 to infinity.
Integration from 0 to
Right into
Yes.
FCS
FCS, correct, into
Cos
cos
x.
SS ds.
Yes.
cos Sx or xs into
ds.
Yes.
ds, right? So this is what will be the definition of inverse FCT. Write the question. Find function f of x if its Fourier cosine transform. If its Fourier cosine transform is e raised to minus s. Okay, what is given to you?
F of S.
Of x.
Find f of x. If its Fourier cosine transform is given, means what is given?
FCS.
FCS, right? Given is Fourier cosine of the function, that is FCS, Fourier cosine transform, is e raised to minus s, and asked is f of x. So we have the definition formula. F of x is in terms of FCS. We have this formula to find f of x, so you can use that. Root under root 2 by pi, 0 to infinity, FCS cos Sx ds. So whenever it is the function f of x, you need to find, whenever you need to find it in x, you should integrate with respect to s. Okay, so it is root 2 by pi. What are the limits of integration?
0 to
0 to
infinity.
infinity.
Right, not provided. So as it is, FCS is e raised to minus s into cos Sx ds. Right, so we have to solve this. Let me take forward. Root 2 by pi integration 0 to infinity e raised to minus s cos sx ds. What is A?
-1.
Correct. What is B?
X. X.
X. Is this correct or it should be S?
X.
X,
Correct.
right. It is correct. And what is the formula? Integration e raised to ax into cos bx dx.
E raised to x upon a square plus b square
Right?
into a cos bx
Correct.
plus b sin bx.
Correct. Plus b sin bx. For cos, there is plus in between. Okay, so it is root 2 by pi as it is. Whatever e, that is as it is, upon a square plus b square. 1 square plus x square.
-1.
Right, it is -1. -1 square. A is -1. Yes, e raised to ax, a square plus b square into a. A is -1 into the cos as it is, cos sx plus b. So plus x, cos becomes sin, sin sx. And this whole is from 0 to infinity. Right, so we'll put the upper lower limits. If the upper limit is infinity,
0.
now, oh yes, you are placing over which variable, s or x?
S.
S, right. So if s is infinity, it becomes e raised to minus infinity, that is
0.
0 into all those things are 0. Minus low limit, if s is 0, e raised to 0 upon 1 plus x square into minus cos 0 plus x into sine 0. Root 2 by pi. So e raised to 0 is 1. So minus 1 upon 1 plus x square into minus cos 0. Cos 0 is 1.
1.
-1, right? Sine as it is. Sine 0 is 0. So this is 0. Means your answer can be root 2 by pi. Minus minus becomes plus 1 upon 1 plus x square as the required f of x. And it should be in x. Yes, it is. Any doubt? Any question?
No.
Good. Next step. Find f of x. If its Fourier cosine transform is, if its Fourier cosine transform is 1 upon root 2 pi k minus s by 2 when s is less than 2k and is 0 when s is greater than 2k. Okay, solve this. What is given to you? And what is asked? Do you get the question? Find the function. You have to find f of x. If its Fourier cosine transform FCS is given to you, you have FCS and you have to find f of x, means which definition you will apply?
Inverse.
Inverse. Very good. So we have inverse Fourier cosine transform, where we get f of x. What is the definition? Under root 2 by pi, 0 to infinity, FCS into
Cos xs
cos sx d
s.
s, right? ds. Correct. So now you have this value, just put it over root 2 by pi integration FCS is otherwise 0. This is the value of FCS. I'll write 1 upon root 2 into root pi or root 2 pi together, k minus s by 2 cos sx ds. But this value is on this interval. So what is that interval? What will be the integration limits? It is from 0 to infinity, but when it is greater than 2k, the values are 0. Up to 2k, the value is this. So what are the limits?
0 to 2k.
Correct. We are going up to 2k, where s, it is with respect to s. So whenever s is less than 2k, it exists. But when it is greater than 2k, the value is 0. So 2k to infinity, it is 0. But up to 2k, it exists. So lower limit is 0. So 0 to 2k. Right. So here, root 2 by root pi. 1 upon this will come out root 2 into root pi. Integration 0 to 2k. K minus s by 2 into cos sx ds. Root 2 cancelled. Root pi into root pi.
Pi.
Pi. Chalo, we'll take it forward. So f of x is 1 by pi. Integration 0 to 2k. K minus s by 2 into cos sx ds. How will you solve this?
Leibniz rule.
Right. It is with respect to s. So we'll see how many s function are there. So this is one first function, and this is also the function of s. You should take care of the variable. If it is x, dx, so we'll check the functions of x. But as s, we are checking functions of s, two functions of s. And we'll now check whether any one of its derivative will get 0. Yes, derivative of this will be 0. So next means second derivative. So the whole, this we can call u, and this is integrable, so we'll call it v. And now you can apply Leibniz. U as it is into v1, integration of cos,
Sine.
Minus
derivative minus sine, sine
Sine.
sx, right, sine sx upon what?
X.
x.
X, because with respect to s, x is constant. Then negative sign and derivative of this.
Minus 1 by 2.
K is constant, its derivative is 0. And derivative of this with respect to s is minus 1 by 2. Very good. And the integration of sine?
Minus cos.
Sir, minus cos sx upon x, but
X
already 1x, so x squared. Right. And next derivative of this will be
0.
0 as constant. So this is from 0 to 2k. Right. So now you are placing the limits for which variable?
S.
S. So S you are writing first 2k here. So it is k minus 2k by 2. 2 cancel, k minus k. Okay, chal. Right, just write it down. K minus 2k by 2 sine 2kx by x. 1, 2, 3 minus 1/2 cos x into 2k upon x square. Upper limit done. Minus lower limit is, you have to write s as 0. So if s is 0, it is sine 0. Sine 0 is 0. So 0 into all these things are 0. Minus 1/2 cos 0 upon x square. And we'll just finally collect 1 by pi. Here 2 cancel, k minus k is 0. So 0 into anything, this is again 0. This remains, so which is minus cos 2kx upon 2x square. And this is minus minus plus Cos 0 is 1. So 1 upon 2x square. So if you can see 1 upon 2x square, we can see common. So we'll take it out. 1 by pi is there. 1 upon 2x square comes out. Here is 1 minus cos 2kx is the answer. So yes, if it is there, very good. If it is not there, I'm taking it forward just a minute. F of x we have got 1 upon pi into 2 what? 2x square. 1 minus cos 2kx is this what we got? This. Okay, so this answer is, if it is in MCQ, very good. If it is not there, the second can be, or we have some formula like this. Do you remember 1 minus something cos 2 theta? What is
2
that?
sine
What is that formula? Sine square theta. Sine square theta is 1 minus cos 2 theta by 2. Is this?
Yes.
Right. Correct. So that by 2 I'll check in for the formula. It is there. We can take it here. So it is 1 upon pi x square, 1 minus cos 2 theta upon 2. 1 minus cos 2 theta upon 2, it is sine square theta. So this is sine square kx.
Yes.
This is also okay. Done? That is the answer. Sine square kx upon pi x square. All those answers are okay. Shall we solve one question? Next one. Find Fourier cosine transform of Fourier cosine transform of e raised to minus x, where x is greater or equal 0, and hence deduce that integration 0 to infinity cos mx upon 1 plus x square dx is pi by 2 e raised to minus m. I think similar question we have solved in sine transform also.
Yes, only x is not there.
Right. Can we try? Just try.
Yes.
Let f of x is e raised to minus x. Call it function f of x. You have asked it Fourier sine cosine transform. So it is FCS root 2 by pi 0 to infinity f of x into cos sx dx. Right. So it is root 2 by pi integration. Function is e raised to minus x into that cos sx dx as it is. What are the limits? X is starting from 0. No upper limit. So starts from 0 to infinity. Right. Okay. The formula now. E raised to ax cos bx.
Yes.
It is e raised to ax upon a
Minus
square
1 plus
plus
x square
b square, correct, into a cos
sx
dx plus
plus
S.
s sine
sx.
sx.
Correct. B is s, so b sine sx. And for cos, there is plus in between. This is from 0 to infinity. And when it is the upper limit infinity, the value is
0.
0. Minus lower limit is 0. So it is e raised to 0, 1 upon 1 plus s square into cos 0
1.
You are writing x as 0, right? So cos 0 is 1. There is negative sign, so minus 1. And sine 0 is
0.
0. So this is 0. This minus minus becomes plus. So it is root 2 by pi 1 upon 1 plus s square as FCS. So you got Fourier cosine transform as 1 upon, what is that? Root 2 by pi 1 upon 1 plus s square. Okay. And there is the question and hence evaluate and hence deduce this. Means whenever the deduction comes after Fourier cosine, it is
Inverse.
Fourier.
inverse, right? So it is inverse Fourier cosine transform. So where we get the function back to x means f of x is, what is the definition?
Under root 2 upon pi.
Hmm?
Integration 0 to infinity.
Hmm?
FCS cos x s ds.
Cos x dx. D
S.
S. Right. Put that FCS, whichever we have got. To 2 by pi, limits 0 to infinity. FCS is root 2 by pi, 1 upon 1 plus s square cos sx ds. That root 2 by pi becomes 2 pi pi. Integration cos xs upon 1 plus s square ds. So here that pi by 2 will go here and multiply with this, where it is integration as it is. Just check the evaluate part once and tell me. There is cos mx upon 1 plus x square, cos mx upon 1 plus x square dx. So yes,
X
we
m.
right, we got that s is x there and x is m.
M.
So first we put x is m. So it is pi by 2 into f of m is cos ms 1 plus s square ds. But f of m is
E raised to minus m.
right. Here you have to write x as m e raised to minus m. So here it is pi by 2. It becomes pi by 2 into f of m e raised to minus m is integration 0 to infinity cos ms upon 1 plus s square ds. Right. But in your show that there is x, so finally we can just replace s by x. Do that changes. So you got the answer pi by 2 is 0 to infinity cos mx upon 1 plus x square dx as required. Write the next question, try to solve. Find f of x. If FCS is root 2 by pi sine ks upon s. Right? Means you are using inverse Fourier cosine transform definition, which is root 2 by pi g to infinity FCS into,
Cos x s ds.
right. So write FCS there. Limits are 0 to infinity as not given, root 2 by pi as it is, sine ks upon s into cos sx ds. Try it. Root 2 by pi, root 2 by pi, 2 by pi, integration 0 to infinity, sine ks cos xs upon s ds. Will you solve?
2 sin A cos B. 2 sin A cos B.
Okay. It will get separate, but there is 1 upon s. There are 3 terms of s. What you will do? Have you heard about DUIS rule? I think you have studied in M2 somewhere, DUIS. What you do there? To solve the integration, if there are 3 or more variables, we just reduce it into 2 and solve. What is that? I want you to study this today. Just see what is DUIS rule. And for DSY students, I don't want to take it right now. In some more lectures, we'll take the revision. There we'll discuss this. For now, you can ignore. But regular students will see today DUIS and how to solve this question. I let it to you as homework. If you are not able, we'll solve it tomorrow. Just before, to solve this, we will need the DUIS rule. Okay, so this is all about Fourier transform. But yes, few definitions we'll need. So we'll write them lastly. So whatever we have seen, Fourier transform, sine transform, cosine transform, these all are infinite. Means it is defined from minus infinity to infinity either. So Fourier transform was from minus infinity to infinity. Cosine and sine are from 0 to infinity. So there was infinity, means it was infinite transforms. All the things which we have seen till now, the infinity was there, all were infinite. So we generally do not use the term infinite, we just use transforms. The next term will come is finite. Finite Fourier sine and cosine transforms. Finite Fourier will write first sine transform. So it can be finite FST. Okay, so there can be 2 intervals where we need to define this. So first is on the interval, say 0 to pi, means if the interval is having pi, and what could be the second interval? If you remember the series,
Pi to 2.
Minus
0,
pi.
okay, forget the pi cover here. And second type is arbitrary, where we have seen 0 to
L.
L, right, correct. So second is this type L. So if it is having pi, if it is not having pi. The first is if the interval is 0 to pi, if it is defined on 0 to pi, it can be F, we are writing Fourier sine, right? So FSS notation is again same, just finite means it is defined on some finite interval and not 0 to infinity. It starts with 0, we know. So 0 is fixed. So upper limit is not infinity but some pi. Then it is defined as integration 0 to pi f of x into sine sx dx. That root 2 by pi is gone. Integration 0 to infinity becomes 0 to pi, and the remaining part is as it is. And second, on the interval 0 to L. So if it is not having pi in it and the number L, any number, then its finite Fourier sine transform is integration. Can anyone tell me 0 to L f of x into, think about the angle as Fourier series. If it
nx
is
pi upon n.
Sine Sx upon L.
only Sx, was that only
Sx pi
Nx?
upon n. Sx pi upon n.
Very good. Sine, we have written there n pi x upon L, if you remember.
Yes.
So if it is sine nx, it becomes sine n pi x upon L. So it becomes sine s pi x upon L dx is the definition. In case of finite, this is the definition of finite Fourier sine. And now next will be finite Fourier cosine transforms. That is finite fct. So first again there will be the two intervals. First is 0 to pi. On 0 to pi, finite Fourier cosine transform will be, can you tell me?
Cos instead of sine.
Right, everything is same, 0 to pi f of x, and instead sine you'll write cos sx dx. Very good. And second, on the interval 0 to L, so finite Fourier cosine transform will be 0 to
L.
L f of
F of x
x
sine cos
into
s pi x upon
cos,
n.
very good, s pi x upon L dx. Done. So in this finite type, inverse finite is there, but never will ask. You can write if you want, just write it down, but they will not ask you. So inverse finite Fourier cosine transform. First you'll write sine, as we have written sine first. So inverse finite Fourier sine transform. It is defined as f of x is equal to 2 by pi. Now again on the two intervals, first is 0 to pi. On 0 to pi, it is f of x is 2 by pi summation s is 1 to infinity. Instead integration will go for summation if it is finite, fss into sine sx. And second, on 0 to L, never asked, so you can just note, but no need to remember. It is never asked. So finite type is never asked. We have times I am writing the definition, you should just note them. So 2 by L, s is 1 to infinity, fss. What will be the change here?
S pi x upon n.
Right, sine s pi x upon L. Angle will change on 0 to L. Okay, right. And similarly, you can write inverse finite Fourier cosine. But I think you should not. And you should not write this also, because if you want, you can write. But I hope you should not write, because it will not ask. Otherwise, that will be more confusing to you if you want to go with. Just we'll write. Chalo, we'll write the next also. As we have started, so we'll end it. So inverse finite Fourier cosine transform. There is the word finite. Please remember, as it is finite, it must be defined on finite intervals. So first, on 0 to pi, now it is a little different than sine transform. So it is f of x is 1 by pi into fc0, whatever your fcs, you will write s as 0, we'll find the value, we'll multiply by 1 by pi to that term, and that will be the extra term. Plus 2 by pi summation s is 1 to infinity fcs into cos sx. This more extra term will be there in finite inverse Fourier cosine transform. And secondly, on 0 to L, it will be f of x is 1 upon, can you tell me?
This term is also here. 1 upon pi
Yes,
fc
yes,
0.
yes. No,
So that
it is
term,
in, yes, it is there, extra term. It is exactly like Fourier sine. This term is like sine, but for inverse finite Fourier cosine, this is extra. And the term is also here in 0 to L, that is 1 upon L. In 0 to pi, that is 1 upon pi, but in 0 to L, it is 1 upon L, fc 0 plus 2 by
L
L summation,
s equal to 1 to infinity.
right, fc
S
s
cos
cos,
s x upon L.
right, s pi x upon L. But I insist that you will not go with this because it is never asked, it is out of the syllabus. Up to we have is this finite Fourier sine and cosine transform. No need to go with the inverse of them. So we'll take few questions on finite and then we can stop. That the question, find the finite Fourier sine transform of finite Fourier sine transform of sine kx if k is not an integer, and 0 less than x is less than pi. Now it is changed a lot, drastically, from Fourier transform to Fourier sine transform, and then again finite.
Fine.
Right? So you have to read all those words properly. So now we have asked finite Fourier sine transform. And for that, interval we should know. So what is the interval?
0 to
0 to pi.
Right. So it is asked on 0 to pi. Now we know this definition of finite FST on 0 to pi. It is FSS is equal to,
integration 0 to pi
right?
f of x sin sx dx.
Right, f of x into sine sx dx. That root 2 by pi is gone, and 0 to infinity is 0 to pi. And inside integration part is as it is. So we have f of x. Do we have? No. So let us call, and let f of x is sine kx. They haven't called it as f of x, so you can now call it f of x. So integration 0 to pi sine kx into sine sx dx. And we know how to solve. We need
Yes,
to,
sin
right?
sin
We need to. 2 sine A sine B
cos a minus b minus cos a.
Minus cos A plus
minus
B.
CC, right?
Yes.
Yes.
That is 1/2 minus cos A plus B, k plus s x plus cos k minus s x. But this is integration, right? Integration from 0 to pi. We are just applying formula. Now we have to integrate both of them. So what is the integration of cos?
Sin
Minus sine as it is
Sine.
then. Sine
minus k
k
plus
plus s x upon,
A plus
k plus s.
right, plus sine
A plus
k minus sx upon k
K
minus
minus
s. from 0 to pi.
Pi.
So first thing you will write x as pi everywhere and then x as 0. So if x as 0, sine 0, 0,
0.
and this is also 0. So it is equal to 1/2 minus sine k plus s x is pi upon k plus s plus sine k minus s x is pi upon k minus s upper limit. Minus there will be sine 0 upon anything. So it is 0. Sine 0 is 0 and this is also 0. So the lower limit is 0. Now sine. What will be the answer? So let it be as it is. We don't know about these values. They are even or whatever. K, it depends on k and s. So we'll let them as it is and we'll write it 1/2. So this is 0. We'll ignore sine k minus s pi upon k minus s minus sine k plus s pi upon k plus s. That can be the answer. Finite Fourier sine transform. But we know sine any pi is 0. But can we generalize here 0 directly?
No.
No. Because it depends on your value of s and k, both the values. So we should check whether it is like sine, is it 1/2? So if it is 1/2, so sine pi by 2 can be 1, like that. So we should have the values of k and s. Okay, done. That is finite. Do the next one. We have time? Yes, we have. Chal. Next question. Find the finite Fourier cosine transform. Find the finite Fourier cosine transform of f of x is equal to x square in 0 to L. Chalo, do that. Can we generalize that L now? Do you want to write it some number instead L? L can be 2. Write 2.
Yes.
Okay. So it is not having pi now. Interval is not having pi. Interval is having L. So finite, what is asked, we will write first finite Fourier cosine transform. So for this finite, you should know the interval. So interval is here not having pi, means it is 0 to
L.
L. And
L
so
equal
you
to
will write compare with the given interval 0 to 2. So we get L is 2. And what is the definition? Fourier cosine transform. Integration 0 to L, correct?
X
fx cos
cos
sx
L
d cos sx, not cos sx. Cos sx when it is having pi,
pi
but when it is having L, it is cos s
S
S
pi
L
x upon L.
dx.
Right, correct. You should take care of this in finite. So whenever number comes and not pi, angle should be s pi x upon L. Chalo, put the values and solve. 0 to L, L is 2. F of x is x square into cos s pi x upon L, L is 2 dx. How will you solve?
Leibniz rule.
Right, so this is u, this is v. Do that. U into v1, integration of cos is sine. Sine s pi x upon L upon
S square
Pi.
pi S
L
pi
is 2. Let me write L is 2. Upon s pi by 2.
2
Minus derivative of this 2x integration of sine
Minus cos.
minus cos s pi x upon 2 upon s pi by 2 s pi by 2 s square pi
Pi
square by 2 square 4, then minus, then plus derivative 2 integration of cos
Sine.
Sine.
sine, so minus as it is sine s pi x upon 2 upon s cube
Cube by
pi cube by 2 cube 8,
8.
and it is complete here. So from 0 to 2.
2.
Okay, so if the upper limit is 2 for x, if it is 2, 2 get cancelled and sine s pi. Or you can write sine s pi. If s is integer, then we can write it as 0. So we have to make sure if it is not integer, s is not an integer, then we cannot write it as 0. Do you getting?
Yes.
Right? If s is integer like 1, 2, 3, 4, minus 1, minus 2, then only we can write it as 0. So now we will consider s as an integer. So we should consider s as integer in your answer. So let s be an integer. Then we can write it as 0. If it is not integer, we'll write as it is, no doubt. So write then answer. If x is 2, 2 cancel, sine s pi is then 0. 0 into anything? 0. Second, if x is 2, there is cos s pi. Cos s pi, what is cos s pi? What is cos n pi?
Minus 1 raised to n.
Minus 1 raised.
Right. So sine s pi is 0 and cos s pi, like cos n pi, it is minus 1 raised to n. N is here s.
X.
Minus 1 raised to s. Oh, this is 0. Minus minus is plus. 2 into 2, 4. 4 cos s pi. 4 cos s pi is minus 1 raised to s upon s square pi square by 4. So s square pi square by 4 can go up. So it is 4.
16.
Right. Then here again 2 get cancelled. Sine s pi, which is
0.
0. 0 into anything. The whole term is 0.
0.
Okay, this is the upper limit. Minus now lower limit. If x is 0, sine 0. Or if x is 0, 0 into anything is 0. Yes, this is 0. Again, if x is 0, 0 into anything is 0. And if x is 0, this is sine 0,
Sine 0. 0.
which is also 0. So all the terms are 0 there. That is, your answer is 16 minus 1 raised to s upon s square pi square. But if only your s is an integer, s is when your s is integer. And if s is not an integer, you will write your answer as it is. Just you will write 2 there, baki sab kuch as it is. You will write 0. Lower limit, wherever it gets 0, you will write. Baki, let it as it is. Chalo. So I'll give you one homework. You can try it. Find the finite. So here I'll ask you to remember all the formulae. Find the finite Fourier sine transform of f of x is equal to 2x on 0 to 4. Which type interval?
0 to L.
Right.
0.
What is L here?
4.
4. Good. So here a syllabus ends. That is the end of Fourier transform. So here it ends. But for DSY. Now A plan is in coming lectures we are starting Fourier series, so all are requested to attend as recap.
Okay.
Regular students, and the DSY students, for them we are taking it regularly. Means you can again attend and get it clear. And once Fourier series is done, we'll start revising all other units. So first we'll go with the Fourier series for DSY, because only the unit left for them is Fourier series. Okay, so from next lecture we will start, but before that we should have a test on this Fourier transform. So we'll have it. We'll see how we can do, but here it ends successfully. Can any DSY student talk to me? Anyone from DSY? Be present. Disha is there. आपलं I think stat probability clear आहे, पूर्ण complete आहे. Can anyone talk? Stat probability पूर्ण झालाय DSY चा. Unit number 3. Someone is saying something. DSY student stat probability जमतोय पूर्णपणे. आणि unit number 1 linear differential equations. You will do that आणि next lecture पासून Fourier series सुरू करतो. Okay, someone has asked me when will be our final exam. So I think final exam can be in last week of March.
Okay.
As per my knowledge, it can be in the last week of March or the first week of April. Chalo, so here, but study for the test. Wait, let me take attendance and we can start. Please wait. Wait for 2 minutes. Okay, done. Chalo, bye.